Here is a map of our galaxy, and here is where our sun is within it. Oh, down here it is. This dot is nowhere near a correct scale for our sun, or even our solar system as a whole. Just that one dot is several tens of light years across, but what we can't be, we can see, and all the other stars in the night sky create a better perspective of where we are in the galaxy. In this video, we'll be looking at 3 constellations and the stars within them: the Big Dipper of Ursa Major, Orion, and Taurus. And if we were to place the approximate locations of these stars back on our map here, it would look something like this. Oh, down here it is. Most of the stars we can see aren't too far off on the galactic scale, and about within this circle is just about every celestial object you can see in the night sky. Everything beyond is only seen with a telescope. Let's start with the Big Dipper, or Plough if you're British, which is just the back end of the greater constellation of Ursa Major. It's visible from the northern hemisphere, ideally during summer, and in the general northwest direction. Now I could just go through all the different stars textbook style, giving you their stats and properties, or perhaps we could shift to a more pleasing medium. Welcome to my scale model of our little corner of the galaxy. You wouldn't believe it, but this is the Big Dipper over here. Well, perhaps it looks a bit more familiar down here. From where I'm standing is the approximate location of the sun relative to those stars, at about a scale of 1 to 5. One block is just over 5 light years, so this block here contains not only our entire solar system, but the entirety of Alpha Centauri, which is the other closest solar system to ours. So let's start with the star on the top right. This is Duphi, from Arabic meaning bear, and is the farthest star of the Big Dipper, about 120 light years away from our sun over there. Now, the candles surrounding the star here are the actual stars of the system. You wouldn't believe it, but only about 2/3 of the stars in our galaxy are singular star systems like our own. The remainder are multiple star systems, consisting of 2 or more stars that are gravitationally bound to each other. And in Duphi's case here, there is expected to be 4. Each of the stars here are named in alphabetical order, so we got A, B, C, and D. A and B are confirmed and orbit each other about once every 40 years at a distance of 23 astronomical units, which is farther than the distance that Uranus orbits the Sun. Another couple stars are farther out and are unconfirmed to be related to these two. As to what I've written on the sign, don't worry about it, it's nerd shit. Going down here we have Merak, which is a singular star, an A-type subgiant to be exact. Alright, let's break down what's written on the sign here. The A in A-type refers to the star's surface temperature, or how hot it appears to be. The temperature class is measured on a scale from O to M, which is completely arbitrary. The letters don't mean anything. It's something to do with hydrogen, but just know that O is the hottest, then after B, then A, F, G, K, and lastly M. The number after this is like a decimal, so A1 is like 8.1, 10% down the A range. And finally, the Roman numeral at the end is its luminosity, or how bright it is. 0 is the brightest, and 7 is the dimmest, with Merak being an even 4 right here, which is considered a subgiant. And finally, the 3R next to it stands for 3 solar radii, so 3 times the width of our sun. So going back to Duphi, we can now tell that the primary star is a K-type giant, meaning it's large but not hot, and has a size of 27 solar radii. If you're wondering what our sun is, it's a G2V, a G-type main sequence star, also known as right in the middle. The bottom left of the Dipper is Phecda, which is a binary of an A and K-type main sequence stars. Then above that is Megrez, a singular A-type main sequence star. And then to the left of that is Alioth, another singular star, in this case an A-type giant. Now one more to the left of that we have Mizar, which has an interesting setup. Mizar alone is a quadruple system, a binary of binaries, so these 2 binary systems are gravitationally bound to each other. But a little farther out, almost half a light year out, is another binary system called Alcor, which is suggested to also be gravitationally bound to these 2 of Mizar. Now because we're so close to our sun, still fewer than 100 light years over here, that makes Mizar and Alcor a visible binary, meaning on a good clear night you can clearly make out the separation between the 2. Most of the time, multistellar systems just appear as one star because of their distance from Earth and proximity to each other, but Mizar and Alcor are noticeably separate. And then finally on the end we have Alkaid, which is pretty unspectacular, just a singular B-type main sequence star. The Big Dipper has to be the most popular of the constellations, and it might just be the only one you can confidently point out in the night sky, but don't feel bad as that's the case for most. Thus, the Big Dipper is often used as a guide to find other constellations nearby. If you continue with the line between Merak and Dupi upwards, you'll be led to Polaris, which is the North Star and the tail end of Ursa Minor, or the Little Dipper. If you imagine a line going down between Megrez and Phecda, you will be led to Leo, and a line going east from Megrez to Dupi will lead to Gemini, as well as Orion and Taurus farther out. One final interesting thing near the Big Dipper is not at all visible in the night sky, but can be found by going up roughly the same distance from the line between Phecda and Megrez. Around this dark area here is where the Hubble Deep Field image was taken, which is roughly this size. Here's the moon for scale. So all of that was the Big Dipper, and the Big Dipper is actually a really close constellation of stars to our Earth, only about 100 light years away on average. And for reference, over here is our next constellation that we'll be looking at, Orion, which varies between 250 and 1400 light years away. Now the whole constellation of Orion is actually a bit more than this, but we're just going to be looking at the important parts here in the middle. Now you probably know of the constellation of Orion by the 3 evenly spaced stars that make up Orion's belt, so let's start by looking at those. All of the stars of the belt here are part of the Orion Molecular Cloud Complex, one of the closest and most active regions of stellar formation to Earth. These 3 stars and the complex as a whole are about 1200 light years away, and only several million years old, and is also the home to the famous Horsehead and Flame nebulae. Starting on the left, we have Alnitak, which is a triple star system consisting of an inner binary and a lone outer companion. Alnitak AA is an O-type supergiant, and Alnitak AB is a B-type subgiant. Real far out, you got Alnitak B, which is a B-type giant that orbits the inner pair about every 1500 years. Moving over, we have Alnilam in the middle, which is a singular B-type supergiant. And then at the other end is Mintaka, which is a quintuple system with quite the unusual setup. Let me try breaking it down for you. At the center is an O-type bright giant and a B-type main sequence star, orbiting each other about every 6 days. Farther out is a B-type subgiant, orbiting the pair every 150 years. And then even farther out than that is a binary system, which consists of a B and an A-type main sequence star. So that covers the belt, and the belt is pretty recognizable with its shape and shared characteristics, but the other 4 main stars of Orion are also quite noteworthy, as they're among the brightest stars in the night sky. We'll start with the top left here, a star you might have heard before, called Betelgeuse, a red supergiant about 500 light years away that is known for being one of the largest stars we know of that is clearly visible to the naked eye. It's only about half the size of VY Canis Majoris, which is the largest star we know of, and about 700 times the width of our Sun. For reference, if this one block was our Sun, my little sphere right there would be 5 times smaller than the size of Betelgeuse. It is an M-type luminous supergiant formed around 10 million years ago and rapidly evolving, meaning a supernova is expected to happen within about the next 100,000 years. This supernova is also expected to be quite big, about as bright in the night sky as a full moon, but they say it won't have any negative impact on Earth, so nothing to worry about. On Orion's other shoulder is the far less impressive star of Bellatrix, only about 13 times the width of the Sun, a B-type giant, about 250 light years away. Then going down to the bottom left is the B-type supergiant of Saiph, which is around 650 light years away. And then on the bottom right is Rigel, a quadruple system about 850 light years away. The main star of Rigel is a B-type supergiant, which is based in the middle, and orbiting it every 24,000 years is a pair of B-type main sequence stars, and then there's another one orbiting them. And so those are the 7 main stars of the canon Orion constellation, but also associated with it is this diagonal road to the bottom of the belt, which is referred to as Orion's Sword. To do a quick rundown of that, we got 42 Orionis at the top, which is a triple star system around 900 light years away, a B-type main sequence primary along with 2 somewhat unknown companions. The star to the bottom of the sword is Iota Orionis, a quadruple system about 1300 light years away, consisting of an inner pair with 2 outer companions. And then finally, and most interestingly, is the middle star, which is actually a nebula, the Orion Nebula, around 1300 light-years away and about 25 light-years across, making it easily the most visible nebula in the night sky. Directly to the right of Orion is the constellation Taurus, which is most identifiable by this V shape, which is meant to be the head, within the two horns going up to the left and the body going off to the right. The most remarkable star of this constellation is the bright evil red eye of the bull, which is called Aldebaran. It's a real close K-type giant, only some 67 light-years away, and what's this, 6.4 jillion years old? Oh, billion. But that's still quite old, at least for the star that's clearly visible. Only Arcturus in the constellation Bootes over here is older, at around 8 billion years old, which, for reference, is in a universe that's only about 13 billion years old. Aldebaran is believed to be a binary system, but its companion, Alpha Tauri b, is an especially faint M-type main sequence star orbiting at least 680 astronomical units away, with a radius only about a third of the Sun, leading many to believe that it's actually an exoplanet similar to Jupiter. Going out to the left, we have the bottom horn of Taurus, which is Tianguan, a B-type giant with potentially a white dwarf companion, located about 440 light-years away. Just above it, as it would appear, is the famous Crab Nebula, which is the remnants of a supernova some 6,500 light-years away that's only visible with a telescope. Our scale model here is a bit skewed. The Crab Nebula is actually almost 5 times farther away than it is seen here. The star of the top horn of Taurus is Elnath, a B-type giant around 130 light-years away. Then going back to the head, we have the Hyades star cluster, which consists of Ain, Secundum Hyadum, Prima Hyadum, and Chamukoy. Because all of them are part of the same cluster, they have roughly the same distance and age, at about 150 light-years away and 650 million years old. Another popular star cluster is up here, and called the Pleiades. It's a bit farther away than the Hyades, at about 440 light-years away, and is kind of unofficially part of the Taurus constellation as the upper body of the bull. The Pleiades are also often referred to as the Seven Sisters, as there are at least 7 of them, but in Japanese the name for them is Subaru, like the car, hence their logo. For the rest of the body, we got Lambda Tauri, which is also known as Sadra Tauri, a triple star system consisting of a B-type main sequence and an A-type subgiant, and a much smaller companion farther out. Then continuing down the body, we have Kai Tauri, a quadruple system of mostly normal main sequence stars, consisting of a binary in the middle, another orbiting those 2, and another farther out orbiting those 3. And finally, seeming right beside that is Omicron Tauri, a binary of a G-type giant and an uncertain companion, about 270 light-years away from Earth, and also the last stop of today's tour. I recognize that this video may not have been as entertaining as my others, as it's full of numbers and nerd shit, but at least I found it an interesting subject to research, and hopefully you found it an interesting subject to hear about. Let me know what you thought of the video in the comments, and if you want me to dive into a more similar topic, whether it be more constellations or other extraterrestrial features. I think a video on exoplanets would be quite fun. But thanks for watching, and thanks for 4 subscribers, by the way. I'll see you in the next one.